हाय फ्रेंड्स, वेलकम बैक टू माय चैनल। आज हम लेके आए हैं नया चैप्टर नंबर 6, ट्रायंगल्स, क्लास 10 CBSE मैथमेटिक्स NCERT। सो लेट्स गेट इनटू इट। Hi friends, welcome to chapter 6, triangles of class 10 CBSE mathematics NCERT. Okay, so you would be familiar with triangles and many of the properties from your earlier classes, and you would have studied the congruence of triangle in detail. In congruence of triangle, they have the same shape and same size. Now, in this chapter, we are talking about those figures which have the same shape but not necessarily the same size and are called similar figure, right? So, we are going to use this for Pythagoras theorem, right? So, when you look at the practical applications, we have not measured the distance of moon by taking a tape measure and putting it on Earth, one end on the Earth and the other end on the moon, right? Even Mount Everest, the height of a Mount Everest, we have not measured it using a tape. We have measured it using this property of similar triangles, similar indirect measurements, basically, which we are going to learn later on as to how we're going to do. For now, let's begin. So, what I've done is I have made certain figures here. Okay. So, as you know, when incongruency, if the circles are of the same radii, then they are known as congruent. But now we are talking about similar figures, right? So here you can see that this circle is same shape, and right, so it's of the same shape, but not necessarily the same size. So therefore, all circles are similar, because for similar, it has to be same shape, not necessarily same size. Why is it becoming an alliteration? Okay, so therefore all circles are similar. So if even now, if you look at the equilateral triangles, consider that this is an equilateral. Assume that it's an equilateral triangle, even if it looks or doesn't look so. Similarly, these are two squares. So equilateral triangle, these two equilateral triangles will be similar because they are exact same shape, not necessarily congruent. Similarly, in squares, these are both same shape but not same size. The smaller square is a bigger square, right? What about these two quadrilaterals? If we just look at it, the figure number 6.2, are they similar? We can't necessarily understand whether they're similar or not, right? The only similarity is that yes, they have 4 sides. But what else do we need to find whether they are similar or not? That's the question. Now, okay, so your passport photograph. Basically, there's a stamp size photograph. Then it is extended in all directions to make a passport size photograph. Right? So these are similar. Right? So what does it say? Two polygons of same number of sides are similar if their corresponding angles are equal and their corresponding sides are in same ratio. Understood? So this is what we can conclude from this. Right? Now let's look at an example. Okay, so let's look at this activity. We have placed a light bulb over here, right? And we have placed a cardboard shaped in the form of a quadrilateral right underneath this light bulb. We see that there is a shadow of this quadrilateral underneath it, which is same in shape. Shape is same, right? And in fact, what we can say is that these angles are equal, right? These angles are equal. And these sides are in same proportion. So therefore, AB divided by A dash B dash is equal to BC divided by B dash C dash is equal to AD divided by A dash B dash and CD divided by C dash D dash. And all the angles, angle A equal to angle A dash, angle B equal to angle B dash, angle C equal to angle C dash, angle D equal to angle D dash. So therefore these are similar. Right? So as I said, two polygons with the same number of sides are similar if their corresponding angles are equal and the corresponding sides are in the same ratio, which we saw was the case in this. Similarly, let's look at another example. Right? In this case, we can see that the angles are all equal. This is an angle. Okay? These are two polygons of side 4, so it's a quadrilateral. Angles are equal. Now let's see the ratio of the sides. 2.1. 2.1 divided by 4.2, 1 by 2. 1.5 divided by 3, 1 by 2. 2.5 divided by 5, 1 by 2. 2.4 divided by 4.8, 1 by 2. So all are 1 by 2. Sides are proportional or same ratio basically. So therefore these are similar. Now what about these two figures that I have shown here? It's a square. One is a square. Angles are equal. And one is a rectangle. We can, of course, by shape itself, we can say that the shape is not same. But going by this side proportion thing also, 3 by 3 is not equal to 3 by 3.5. Right? 3 by 3.5, 3 by 3. So not similar. So let's look at some questions. Looking at exercise 6.1, it says that all the circles are blank, similar or congruent. So we know circles could be of different radii, right? So they are all similar. Now, they are not congruent, but supposing there are two circles who are the same radii, then they are congruent. So are congruent circles similar? Yes. So all congruent are similar, but the vice versa is not true, right? So basically congruent is a subset of similar. Okay, next question. All squares are similar, right? That's the answer. All dash triangles are similar. Options are isosceles. So in isosceles triangle, two sides are equal. And in equilateral, first option is isosceles and second option is equilateral. So which one are this? All the triangles are similar. So equilateral may, so what was the this thing? Angles have to be equal. Equilateral we know 60 degree. and the sides are in the same proportion, right? If all are 3, then 3, and suppose another triangle equilateral triangle is 5, so then 3 by 5, right? So all of are same proportion. So all equilateral triangles are proportional, right? So we've done some questions. Now we have another question. This is question number 3, right? So here it says that the sides are all 1.5. Okay, and now we have a square where the sides are all 3. So if you look at the sides are in the same ratio, right? All the sides, all corresponding sides are in the same ratio, 1.5 by 3, 1.5 by 3, right? Which is 1 by 2. But are the angles equal? No, clearly not. These are 90 degrees and these are clearly not 90 degrees. Not equal. So not similar. Okay. Moving on. Okay. Now we are going to look at similarity of triangles right? So what is similarity of triangles? Similar to the other polygon, right? So here the sides are of number of sides is 3. So it has to be that all angles are equal and sides are in same ratio, right? One important point that needs to be written here is all corresponding angles and all corresponding sides are in the same ratio. So if there are two triangles whose corresponding angles are equal, they are known as equiangular triangles, right? The ratio of any two corresponding sides in equiangular triangles is always the same, and it is believed that this is known as basic proportionality theorem. Basic proportionality theorem, right? So let's look at it further. So let's look at this theorem first. Just state it in your book. It says if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, right? The other two sides are divided in same ratio, right? So what does this mean? What does this theorem mean? Let's look at it more closely. So it says that supposing we have a triangle like this, right? A, B, C. We have a line DE, which is DE is parallel to BC, right? So what is given? DE is parallel to BC, and this implies, as per this theorem, that AD by DB, that this parallel line is intersecting the other two sides in distinct points such that they are in the same proportion. So this is what it is, right? So let's try to prove this, right? So what will we do is we'll draw a line perpendicular to this, right? And similarly, we'll draw a line perpendicular to this. Draw BN perpendicular to AC and EN perpendicular to AB. Join DC and DE. Okay, so that we have joined. Now what we are going to see is what is the area of okay. Now we are going to see what is the area of triangle ADE. Now you can see that this area can be expressed in this. ADE has two altitudes, so it can be expressed in either of it, half base into height. So how can it be expressed? Half AD into EN, or it can also be expressed as half AE into DN, because DN is perpendicular to this, altitude of this, right? Now let's look at more. BDC, right? What is it? Half. Now for BDC also, this is the altitude, even though it is outside the triangle BDC, right? So, but the altitude remains EN only. Into BD, and if we look at area triangle BEC, it is equal to half DN into EC. Now, so we already know that this is one point, right? Sorry. Okay. Now what about these two triangles? BDC and DEC. They are drawn on set of parallel lines with the same base, right? So that means the areas are equal, right? So the areas are equal, so we get two equations net. One equation is okay. So one equation from this is AD into EN is equal to what? AE into DN, and from the other two the equation is EN into BD is equal to DN into EC, right? So what can we do now? We can simply do 1 divided by 2. So ये पूरा डिवाइड कर देंगे. So ये कट जाएगा, ये कट जाएगा. So what does it become? This AD by PB is equal to AE by EC. Hence true. So what is the theorem again? DE is parallel to BC, so it divides this triangle in equal proportions, right? So that's the theorem. Is the converse of the theorem also true? So what would be the converse of a theorem? Is the converse of the theorem also true? So what would be the converse of a theorem is that we know that a particular line, right? We know a particular line exists like this, And we know that given AD by DB, this is already given. So we have the other converse of the theorem is that DE is parallel to BC. How do we prove? To prove this, right? So proof. What will we do is we'll make a line DE dash which is parallel to BC. Now if it is parallel to BC, then AD by DB is equal to AE dash by E dash C. Now from this is already given, right? AD by DE BB is equal to AE by EC. And from this line, this becomes equal to AE dash by E dash C. What does this imply? E and E dash coincide. And hence, DE is parallel to BC. So this is the next theorem that we just did. Right? So let's move on to examples. Let's move on to certain examples. So for example, the example is given is there is a trapezium and these are the parallel lines. Right? AB is parallel to BC. Okay. And now this is another not made it straight, but what we've done is that there is another line drawn such that that line is also parallel to this. And net these are all parallel lines. These are three parallel lines. So what do we need to show? We need to prove that AE by ED is equal to BF by FC. To prove. Right? So what can we do? So we can just join this line intersecting at G, right? So first let's take triangle ADC. EG is parallel to BC. So by theorem 1 that we learned, AE by ED is equal to AG by GC, right? That's what we are able to see. Now let's look at another triangle. Let's look at triangle ABC. Here GAF is parallel to AB, right? So CG by GA is equal to CF by FB. Now inversing this, GA by CG is equal to FB by FC or PF by FC, whatever. Now looking at 1 and 2, the left hand side of 2 is equal to the right hand side of 1. So then that means these equations are equal. So net AE by ED is equal to FB by FC, which is this. Hence proved. Understood? When you're writing in the exam, you have to write it out in steps. I have just told you the answers as to how should we go about doing it. Let's look at another case. Okay. Okay. Question is, it's given that PS by SQ is equal to PT by PR, and angle PST is equal to angle PRQ. That means this angle and this angle are equal. Right? That's what's given. To prove triangle PQR is isosceles. Okay, isosceles means any two angles are equal, right? So let's look at the proof. First, it's given that PS by SQ is equal to PT by PR, which will imply PS by SQ is equal to PT by PR. Given. So what does this imply? ST is parallel to QR by theorem 6.2, right? Now if ST is parallel to QR, then angle PST is equal to angle PQR, corresponding angles, right? Now also given is that PST is equal to PRQ. This is given. So from 1 and 2, what can we conclude? Angle PQR is equal to angle PRQ. Hence, prove that this triangle is an isosceles triangle.
होपफुली आपको आज के कॉन्सेप्ट समझ आ गए हों. If you have any questions, queries, doubts, if you want me to solve any question again, explain any concept again, let me know in the comment section below, or you can send me an email, or you can mention or comment in any of my social media handles. Till then, like, share, comment and subscribe to my YouTube channel.